So I'm willing to bet that when you think of fractions, you don't pause to consider how deeply they've moved your soul. And when you see an algebraic expression, you don't marvel at its beauty and its power. I have a confession to make. I love math, but that's a hard thing to admit when most people think of math as something that is done to them, something they survive. I remember the day my brain finally came online, sitting in Mr. Kreitch's Physics 11 class, where we learned the astounding fact that we live in a universe that is describable through mathematics. And up until that point, I had thought of math as some set of strange rituals you perform in order to get the answer at the end. Now, as a teacher, I've always wondered how many of my lessons stay with my students into adulthood. And so with that in mind, we're going to have a pop quiz. So I'm going to ask you 3 questions. And I just want you to raise your hand if you're confident that you can answer each of those questions. Ready? Here we go. Question 1. Question 2. Question 3. So if you didn't like that last part, you're going to like this next part even less. Because these are the ages where we expect our students to master those concepts. And right about now, you might be trying to rationalize why it is you can't solve some of them yourselves. You might rightly point out, well, it's been a really long time since I learned this, and how can I possibly be expected to remember? Okay, fair enough. We could just compare these to the other things you were learning as a 10, 12, and 14-year-old student. Can you write a paragraph? Can you explain how and why we breathe? Can you navigate the complex social interactions of adult life? So you've probably heard it said that math is like a language, and languages are temperamental. When we use them, they stay fresh, and then when we stop, they fade. But this is getting to the heart of the problem, because if you don't truly believe that you're using math all the time, then we've missed the mark. Remember when I asked you if a fraction had ever moved your soul? If you said no, then that's probably because we neglected to mention that the meter and scales of music are nothing but the complementary layerings of fractions of waves. So granted, that's not exactly the symphony, but that's not bad for a couple of test tubes and a 15-minute talk on multiplying fractions. See, I worry that we're teaching math as a sort of proxy for logic. And math is inherently logical, and yet solving math problems does not necessarily require any logical thinking whatsoever. I'm worried that we're sanitizing these ideas into these bite-sized morsels, each one simple enough to master, yet vague enough to lose any connection to its original meaning. Now, our students, by the time they graduate, will have had at least 12 years of math instruction, and that equates to thousands of hours of math learning. What's our return on that investment? Eric Mazur is a physicist and professor at Harvard who asserts that any test question which can be Googled is an invalid test question. And I want you to pause and think for a second. How much of your math education could have been Googled? And while you think about that, I want to show you one last thing. See, before coming here and trying out my little pop quiz, I tested it on the only person that I could convince to do it. Unfortunately for her, it was my 5-year-old daughter. And luckily for her, she was armed with the internet and some speech recognition software.
So x squared minus 5 x plus 6 equals 0.
What does it say?
It says 2 and 3.
What does that mean? Now, I know some of you are probably saying, isn't he just using this as an opportunity to make his kid look like some sort of math genius? And to those people, I would say, you're damn right I am. And more to the point, what this shows is that with the right tools, all of our 5-year-olds are math geniuses in terms of their abilities to compute. The mechanics of math have literally become child's play. But what I want you to do is pay attention to her answer to that last question. Of course she has no idea what it means. She has no context, no foundation for that knowledge. My question for you is, how are we going to make sure it's not the same thing for our 10, 12, and 14-year-old students? Thank you.